our original intended session because Zacck wants to share a little bit about the RTFES platform that he's been working on with a couple other members of the community. And if you don't know what RTFES is, then I'm going to drop something into the chat for you. You can see it here. If you're part of the Discord server, which is at discord.gg/devheads, you'll be able to go in and check out this what amounts to an OTA update platform that we've been building. And the idea here is to put build a library basically of hardware and allow users to flash it and then eventually hopefully do a little bit more than that. So he's going to be explaining some of the progress that he's made, so that's going to be cool, and then seeing how we can integrate all the content that we've been doing around this AI and free RTOS gesture control project with that infrastructure. So that'll be fun, and we'll just give him a second because I know he's juggling lots of stuff. How are all you guys doing today? I've also got to get the Discord folks in. Maybe he's over here already. Oh, yep, there he is. Oh, still not sure how to use the platform. Zacck, you there? He's getting ready, he says. Dude, you guys, it's like you guys are building an OTA update platform but can't figure out how to use the webinar tool. Yeah, it's awesome. You're muted.
Webinars are hard.
Webinars are hard.
Yeah. Okay, so we sort of need, I don't know, I know this has already started, Brandon, but we sort of need some sort of moderator. Bernard is here as well. We sort of need a sort of moderator to do some sort of fireside chat about this.
Yeah. Well, we'll definitely do that. We'll definitely do that on an upcoming office hours. Are you talking about doing it right now?
Yes, that's the only way. That's the only way we're going to demo what we have. Otherwise, everything's broken because we just started a new part.
Well, I can be a moderator. I've done this for my entire career, so I'm happy to fill the void. While we're filling the void, let me just start the stage over in Discord. So, Zacck, while I'm doing that, why don't you introduce Bernard?
I'm waiting for him for his desk to go quiet. Okay, so hi everyone. This is your engineering hours. Welcome to your weekly engineering hours from DevHeads. This is where we build production embedded or IoT products, and we try and showcase them truly as they show up. So we include all the missteps and we include all the mistakes and everything that we do in our journey to this. And as everyone knows, for the last couple of weeks or maybe 3 weeks, we've been working on the remote embedded testing platform that's coming from DevHeads. One of the core contributors of this has been Bernard, who is coming up with our proof of concept P2P application that lives on the server and streams binaries from developers to microcontrollers, and also video from microcontrollers to developers. And Bernard's been working on this for the last few weeks. I've known Bernard since 2011 or 2010, somewhere there. We've done quite a lot of open source work together, and Bernard happens to be one of the people who taught me how to develop for Android devices when I was leaving university all those years ago. But yeah, Bernard, why don't you tell us what you've gotten up to with Linux and kind of your background and why you're excited to work on this? Really, that's it.
So from this meetup, I don't know who we are talking to, but I've loved Linux for a long time because it is open. And when I went to university, I studied operating systems, and Linux was just right at the center of it. So on the side, I was doing things to do with developing device drivers, writing basically device drivers, and writing, playing around with the operating systems. And then I worked in an operating system company. We were called Miracle Linux on a project called Zacck. So everything was our Red Hat, basically. It's the company that built the regional versions of Red Flag Linux that is used in China now. Yeah, but I started coding when I was young. I just liked coding, but built Android stuff, built apps, and what else? I like embedded. Someone told me if you like something, you keep it on the side. You don't do it as your core job. But like we worked on different projects. I think my last big employed work was writing firmware, operating system for a firmware using OpenWrt for a company called Brick. Using OpenWrt, it was for a Wi-Fi device. So I learned a lot about Wi-Fi at that time. And OpenRT, which is different. And then what else? Yeah, but on and off. After that was like almost 4 years ago. And then I've been doing on and each and every year, I must get an embedded stuff that I do on the side. On my day job is as a CTO of mobile. We are building a mental health app. It's Android, iOS, but I get my hands dirty with embedded stuff. Last year was a very exciting one. We worked with. I can just say it was a military thing, so I cannot go deep into that. But it was really awesome. Yeah, and then this one also is now really great. I think 3 months ago we talked with Brandon. He was supposed to send me some device for me to play around with, but then that. So. But then this project comes where we can basically do this remotely, and so I just thought, oh wow, it's a really, really cool thing. It's a problem many people face. Engineers are not where the device is, and it takes 2 or 3 weeks or even a month to get the device there. So why not write the code? Because you can always write the code and run it somewhere where the device is. I think it's a really, people have them. I think in-house they have different kinds of things, but I think it's important to have such a thing like open source where people can build and basically solve. It's a real problem that is there. So it's an exciting thing. It has taken a lot of my juices. Originally it was very, very, it was a simple thing. I think Zacck thought we'd hack it over a weekend, but when we got into
let's take a step back because I don't think anybody really knows exactly what we're talking about. So let me do my little preamble first, and then we can jump right in. So as Zacck said, this is Engineering Hour, and Bernard, this will give you a little bit of taste of who's here too. Every week we do an engineering hour, which is separate from the office hours that we do on Fridays, where we talk more conceptually about things. In engineering hour, we're trying to do some real application of technology to real world hardware and software and build stuff. So over the last several sessions, we've had Zacck doing development of an AI gesture recognition application with free RTOS, and there's some projects that he's been developing and sharing with the community. And Zacck, I don't know if you could pop those into the chat here, the links to the GitHub repos, but those of you who are already started, great, keep on trucking. And those of you who have not been attending these or have not been exposed to the project and the code bases actually now that Zacck has developed, you might want to jump in. The reason that this is a little bit of a mod from the original planned session today was that we wanted to talk to you guys about what challenges you were having with the project that Zacck has created and shared. You can see it now in the chat over here, the repos that he's got. And we're still planning to do that. We still want you to let us know what things that you're experiencing and the trouble you're having. And, of course, you can always do that directly in the Discord server as well. However, we also want to introduce this tool, which is important because one of the things in my life, for those of you who don't know me very well, is I'm a technology journalist. I've been an editor for about 15 years, and that means I go to a lot of trade shows, meet a lot of companies, and I get given a lot of hardware that people want me to do reviews on. Now, the problem is that over time, those things start stacking up on my desk, and I just don't really have time to do anything with them. And this has happened to a couple of us over the years. So rather than just letting them collect dust, over time, I've tried to figure out things to do with them that are productive. And this is probably the most productive thing I could think. What this platform that Bernard and Zacck keep referring to is RTFES. Zacck calls it the remote thing for embedded solutions. I call it remote testing for embedded systems. But either way, the most important thing is that it's remote and it's embedded. And what that means is that essentially we're building towards having a system that will allow you to flash a real target that is located somewhere else remotely. Right now, it's Zacck's place in South Africa. The lab may not end up being there. It may end up being somewhere else. But for right now, Bernard, you're in Kenya, correct, Bernard?
Yeah.
Yep. Bernard and Zacck have been working on building out this infrastructure, and we want to keep adding to what amounts to, a lab that everybody can jump into and test out hardware that they either can't get because it's too expensive, you can't get it where they are geographically, they just want to try something out. And really the hope is to be able to timeshare this. So we would set up some sort of round robin scheduler or something like that so that you could pick a time slice and then jump in and flash, the hardware, especially as we keep building out these projects and sharing out code and examples. You will have the actual hardware, which make it a lot easier. And we're also talking to some of our industry friends to see if there are ways that we can pull in other cool stuff, other infrastructure. We're talking to some friends who do some CI and CD stuff. There's a potential at some point of hooking up an editor there and allowing you to do a little bit of, more advanced debugging maybe, but don't hold us to that. This is stuff that's roadmap. Right now, we just needed to get the baseline in. So that's what Bernard and Zacck have been talking about. And I'm not sure what your plans are to show today because I've seen portions of this. I haven't seen everything. So at this point, Zacck, I'll go ahead and pass it over to you with the one caveat of saying, for those of you who, if you have any trouble today with the stream, you can just DM me. I'm either at TechieLou in Discord or at Brandon in the webinar platform. And I'll be happy to help you out. So with that, Zacck.
Yeah, thank you. So like Brandon said, we've been working on this remote tool for remote thing or tool or for embedded systems. And one of the difficulties that we've faced so far is, in the beginning, we thought sending a binary was going to be the difficult part. But what has turned out to be difficult so far has been actually delivering video of the running binary on the website, so that you can, on the same interface that you can use to, I think I'll open it just now since I'm talking about it. So we can do a dry run, and just as we understand stuff. So ideally on this system, it's obviously, this is a proof of concept. It doesn't look exactly the way it's going to look. What you
need some UI work.
Yes, it's going to need UI work. But before we get to UI work, it needs to work properly, and that's what we're prioritizing at the moment. As you can see, as Brandon has explained, the team is very skinny. It's just I and Bernard, who both have full-time jobs and are not working on this full-time, and we're squeezing as much time as we can to get this working in good time so other people can use it. We like it. We like doing it. So the theory of operation is, I can probably try and do, hopefully this doesn't crash it, Bernard. Oh, already did.
By that,
If you can restart that module for me, please. So the theory of operation is, we have I can probably use this as well. I could probably tap my phone as well, and that will work as well. Okay. The theory of operation is, you have a microcontroller, is sitting in some room somewhere in the world, and you have an ability through a website such as RTFES, where you can choose a binary. So I'll go choose one so that you guys see how we arrive at a binary. So let's do something like, how do you make it so it goes, I can have okay, let's go my workspace. I can go into my workspace, and I can pick out, I think, something like general timers. So where's general timers? General timers. I'm picking out general timers because it's the biggest, flashiest thing I can find in my code. Has a lot of flashing LEDs.
You skipped over it.
Yeah. Okay. So you go into your project, you go into the build folder of your project, and probably if you're building for debug, you can find the debug project, and then you'll find your builds, which is somewhere here. I should have a binary file somewhere here. Why can I not find anything today? Oh, cool. I see that. So if you go into your project and you're going to build, you'll find something like this blank keep system bin, which is your build. This is the executable that you built from your project. If I open that here, I can upload that bin. Now, let's look at what we've ended up having. So we have a successful file upload, and we have a token that enables us to identify that we've uploaded some sort of file. And what happens is, then we have a run schedule, which is, I think, 10 minutes from now, probably, or even maybe now, immediately now, because this is...
There's no queue. Yeah.
Because there's no queue, we got the most immediate slot. So it wants to give us the current 15 minutes to run. And then after that, basically what you're supposed to see is... did you restart this, Bernard? Yeah. Let me see. Yes, but can I choose a different camera? Yes, so I can do this. No, I don't have a Nokia 3310, I'm just pretending. So there's a device here. Technically, this is you're supposed to see this footage that you're seeing right now. I'm gonna be all over the place. Technically, this footage that you're seeing right now. Bernard, are we gonna get footage? Don't worry about that. So the footage that you're seeing right now, yes, amazing. I'm gonna pause because it's gonna crash soon. Don't worry about why it's gonna.
It's not going to. It's just like we were fixing something, so it was off.
Okay, cool. So let me explain. There's a webcam here. This webcam is the one that's supposed to be delivering the footage that we are seeing. There's a microcontroller here that shows the microcontroller that is running the actual bin whenever you do upload. So if you do upload the general timers, if you do upload that bin that I just uploaded, it should be somewhere recent or something. That's okay. Space, general timers, and then there's blank kimsys.bin. That's it. That's a binary. If I do upload this, and I upload it, we have an error. Don't worry about that.
What is that?
Yes, I think the same file twice or something. But what is supposed to happen is we're supposed to get a session time, and then during that session time, we're supposed to be able to see the footage of the microcontroller running our binary. And once you do enter the token that is supplied, you get a rerun button, and you get a stop button. You get a reset, and you get a stop button. These are abilities to stop your code, run it again, upload it again, and so on. Basically, what we're doing is, as Brandon explained, we're slicing time into minutes, into time zones. What is it? What do we call the round robin time slots? We're giving everyone a time slot. You get 10 minutes. Wilson gets 10 minutes. Wafa gets 10 minutes. Ashraf gets 10 minutes. Everyone gets 10 minutes. And as we go further and as we go along, and we have many more devices, that could change. You can hold a device for as long as you need, and such like, and so forth. But right now we're just dividing it like that. And the full walkthrough of this system is supposed to be: you upload a binary, you get a scheduled time, and through this webcam that is here, you get to now see the binary run on the device.
So the Pi,
yeah,
the Pi is supposed to pull the binary, and then
yes,
it will flash it at that time.
Yes.
And and then you'll see how it runs. So if
Yes.
you enter the token down here, you'll be able to see. You'll have the ability to. So I don't know why I didn't work. You'll have the ability to redo that time slice.
Let me show you here. Now you can demo that copy. So if you do enter this token here, I have to use a mouse. Wow, that's just me. Sorry. And we submit. We get. Oh, okay. Don't worry.
There's an error also.
Yeah.
I think we are running multiple versions now, so that's probably.
Okay.
But basically, if you put in the token, it allows you to be able to cancel the session or basically rerun it, but within that slice of time.
Within your allotted slice of time. Okay, let me just try and do another dry run. Let's get a dry run of everything working. So this is the problem with P2P. It's not
so
that.
I think I've not looked at the token for another 1 week, so maybe.
Okay.
No, I think we made some changes. But
maybe that's it. Hash or something. Yeah.
So I think it's important too, and while you guys are doing this, I'll explain. So this is a little bit more than just streaming video over the internet, obviously. The system is designed, and one of the reasons that this is becoming a little bit more complex is that the system is designed, as Zacck said, for point-to-point. So obviously that means, I hope most of you understand what P2P point-to-point means. It means that, Zacck is communicating directly with Bernard. And that's necessary because when we have a library or a lab full of hardware, we want obviously multiple people to be able to be doing multiple things or doing, communicating with different hardware at the same time. So eventually we're going to be putting peripherals in place around this hardware. And so we would want Bernard, for example, to be communicating with the SST board while Zacck communicates with a Raspberry Pi. So we had to create this in a point-to-point configuration so that we could scale it in a way that it would be the most useful and we wouldn't have people, sitting in line for hours waiting to use it.
It could end up something like that. So you have an NXP running next to an ST next to the Pi there, and all those three are being used by different developers. But this, at the end, when we optimize this, the footages will all come. The ST footage will be by itself, and then XP footage will be by itself, and the Raspberry Pi for the people who are doing Yocto will be by themselves, and so on and so forth. And that's where the intricacies come, because if it was just from one device, which is from the Raspberry Pi camera to a computer, to a dedicated computer on this side, and on the other side, just one person using it for one board, it's very easy. But the moment there's more than one board to be flashed, more than one time slot to be assigned, more than one sensor or more than one actuator to be listened to, and so you're suddenly dealing with this massive distributed P2P problem, which that's not what you started with in the first place. That's why it's a bit complicated. The more we make the system real, I would say, if that makes any sense.
The important thing is to make the foundation, the core of the system, like really robust. So that's why we have to like test out the different things. So we've done a lot of trial and error, different approaches. But then if the core is very robust, then building around it becomes easier. So it's like just making the foundation like really a really good system, seeing how it can grow off of that.
Yeah, I've been quite busy doing the scripts on the Pi to do the flashing and such. Bernard, are you already building more than one service in the backend? I'm just curious to know, because we are speaking in front of a lot of developers.
We have three services. We have the one that does the video, then the one, of course, that does the filing and the scheduling. Actually, we have two services live now, but I suspect we are going to have another one. Basically, that's it.
Yeah. And I see Umesh says that it looks like a DevHeads virtual lab. I think that is exactly where we're going for. That is sort of what we're building towards. Only that it's going to be on paper, like on the design of this thing on here. On here, this looks very simple because you just have a web portal, and it on paper it even speaks to Discord. It even talks to Discord, and you can launch applications off of Discord, and you can tell the Raspberry Pi to use this GPIO and talk to get logs and such from the devices. But all of these are roadmap items that are coming, and hopefully these are also roadmap items that we can get from some collaborations that are coming in the near future, especially with we might have a chance to add in a CI partner, which would be really cool, because then we can focus more on the P2P and basically reuse a working CI tool. And whenever we can announce that, we'll announce that.
Yep.
For the video, we are using WebRTC because we thought it was most useful almost pervasive, but it turns out that we are having problems with getting it working properly on the Pi. So for some reason, the Raspberry Pi browsers do not really support WebRTC. So we have to do a lot of finagling to get it to work. But I think Raspberry Pi is a good choice for a device that's going to be able to, you can keep it up all the time to monitor the lab. So you can't really get around that. Even when we have other people using the system, most likely they just need a small embedded machine that will be able to stream the video. So I think we just need to get the Raspberry Pi side working. We cannot run away from it.
Can I ask a question, Bernard? So with the way we've been trying with the Raspberry Pi and trying to get it to work, do you see this? Because every time I run into a blocker, it feels like I need to build a module from I need to build a module from blank and then load it into the Pi. Does at some point this become some Linux kernel project where we build something with good video for Linux? Because I have a few.
And I think the problems we've had is, Pi 5 is very new, and so there's a lot of solutions for Pi 4 and the others. And then you are using Pi 0 at the very beginning, which has lower memory, and so does not run a browser. So probably it's just our choice of. Well, we have learned a lot about, even when we were specifying what is going to be used, at least we'll know. But when we finish, I think we'll just package the software in a way that it can be distributed to people can download one package, install it, and that apt install it, or dpkg install it, and it will work that way. So it will be easier for users to use it.
Okay, actually, in our discussions, I've been meaning to ask a question about that P2P version, as you see it. So, and this P2P version was something that you and our friend Bob really fronted when we were speaking about it. How I guess I'm still stuck seeing the trees for the forest. How do you see the P2P version where people contribute their local labs, or maybe we even have big universities contributing their labs? How do you see the setup on their side being, and how do you see, and especially considering, remember we talked about auto connecting to peripherals and sensors and actuators. Is this like a completely impossible thing that we have to do from scratch, or do you have some work you've done in the past that we can sort of apply towards this?
I don't think I've done anything previously like this. But if you have the core of this done well, then it's easier to plug in a P2P angle to it. For this, I think that will build community around the solution, and basically you can ride off of that community. It makes sense for DevHeads, but I think it solves a big problem that lots of people face. So,
okay, that makes sense. Does anyone have any questions about where we are so far and such?
Yeah, I do. Well, Amesh does first. Would like to know if the backend is using Python, Node.js, or Node.js with Nginx.
Yeah, we are using Python.
Python. Okay. Go ahead.
I'd like to contribute Node.js. There was a lot of stuff on Node.js, but I don't know. It's easier for me to scale Python, so I basically just took Python. So the server side is just the file server scheduling is running on Flask, and at the moment the the WebRTC. Oh, come on. Can you guys hear me?
Yes.
Yes.
At the moment, the problem internet connection. The WebRTC is just running over Python script at the moment. We are using selective forwarding, so multiple people can view this site, this image. If you go to,
I'll give him the link.
Well, now we did lose him.
So the internet, Nairobi internet is like this. Okay, so basically, I can explain this further because I kind of intuitive. We are using a Python script to run WebRTC, and then there's a Flask backend service that is building all the backend data synchronization for running bins and scheduling when they need to be run and such, and so on and so forth. That's kind of the thing. Yeah, Brandon?
Yeah. So, okay, let's bring this all back around. So thanks to you guys for those of you who've stayed with us. And, I know that this isn't what we originally had on the docket, but we do want to bring it all together. And the way that we want to bring it all together is by providing, because you were doing that at AI and gesture recognition project on the on an ST, right? On that, was it that ST?
It should run on that ST as well, because that's an F4, okay. And yes, it should run on that ST as well. Yes, but so we have more wires connected to it for the inertial mode sensor.
Okay, so we should be able to make this board available to people who are working on this project very soon. Correct?
Yes. Yes. Okay. So if it's running, there's a number of DevHeads. There's a number of repositories on DevHeads, and one of the first things that we're going to do is make sure all of the repositories on DevHeads are runnable on RTFES, because that is hardware that we already have and hardware that we can already show people. So you should be able to go and modify the AI application and such and so on and so forth. Yes, and other DevHeads projects as well.
So the questions here are, how are we going to do inference on the ML model here? So we're going to have to get a peripheral, right, Zacck?
Yeah. Okay. So that's a good question. Inference is just running the machine learning model. Inference is making the model decide whether the thing is an egg or not. The way you run inference on microcontrollers, as we covered painfully with Taj this past week, is you do have to compile LiteRT or TensorFlow Lite into a library that is runnable on your microcontroller. And then from there on, that library exposes some C++ APIs that you can use to communicate with your model. And by communicating with your model, you're running inference. So it's not something you can see, it's something that happens in your code.
Okay. Nevertheless, we are going to be adding peripherals.
Yes, for sure. We have to.
What peripherals would we be adding in this particular context?
So right now we're going to do motors for this. We're going to do motors for this little system. Where is it? Okay, cool. Yeah, yes. Motors for this 4 degrees of freedom. What is it? Robot hand. So we're going to add motors for that. And this is run on ESP, but we can connect it so that it runs on ST as well. So we'll immediately have an ESP and ST target. And then another primary simpler target is going to.
You're mixing up projects. We're still talking about the gesture control.
So the only peripheral we're adding for gesture control is a MPU 6050 IMU sensor. That's it.
Got it. So I hope that answers your question, Noor. The second question that came out here was from Taj, which was, can we access GDB directly from the platform?
Not at the moment, but eventually, yes. In the next version, after the proof of concept is approved and we have enough integrations, yes, there's, as I said, there's a CI partner that probably is going to help us have PPP pretty soon on the platform. Logs and everything, logs running, rerunning, resetting, and everything. So
Okay. All right. Now here's another part of this. So right now, this is very new. It's a proof of concept, and what we're hoping for from all of you is to help us test it. We want you guys to help us get this robust so that we can add more and more to the system. Like, for example, I mean, it's not uncommon for me to be able to go get some pretty kick-ass NVIDIA hardware. It's not uncommon for me to go get some pretty cutting-edge FPGA stuff. It's not, like these are things that we can get pretty easily, but we can only usually get them once or twice. We can't get them 3, 4, 5, 6, 7, 8, 9, 10 times. And the reason that this is important is that you're going to have access to this hardware. You're going to be able to flash it, and you could destroy the hardware. So we're doing this as a way of giving everybody an opportunity to access this. And right now, we're not yet at a point where we have robust security and sandboxed memories and all of that stuff on the platform. So if you are careless and reckless in what you're doing, you could destroy this for the hardware. You literally destroy the hardware for everybody. So I'm going to send everybody a link to a Calendly here in a minute where you can sign up for a time slice. I'm going to start it towards the end of this week just to give us some time to make sure everything's a little bit more stable and the user experience is a little bit better. Give us some grace where it is new and, it may fail, but, your participation will be helpful, and we want to target a couple of different applications, which we'll provide more information on. But principally, remember that if you screw this up, if you're not careful, you're going to screw it up for everybody. So, we can't afford to just go keep buying hardware over and over and over again. So please, proceed with caution. Hold on, Taj. Go ahead, Taj.
Can you hear me?
yes.
Okay, so about destroying the hardware, so one idea, some idea popped into my head. So while programming, working with the STMs, I ran into such situation where hardware reset and changing the boot mode was the only solution. So sometimes my ST-Link won't detect my MCU, then I have to change my boot mode, and then I have to flush it again, and then I can use it like normal as usual. So I think it would be a better idea if we can add some if we can link the GPIO from Raspberry Pi to the boot pins, so that if something happens, like if it is not responding, we can change the boot mode and we can do it with the software.
Yeah.
Okay.
That's already in the design. We just haven't done it. That was already option, yes.
Okay,
but we still, the thing, Brandon, is the actual solution to the problem that we're facing, that Brandon is describing right now, is going to be in all of the devices that we add to the lab. We're going to have to implement a small bootloader so that we have a user land and a kernel land, and that way kernel can sort of protect the hardware, which is going to be a big open source undertaking because we'll have a lot of devices, but we're also a very large community. We have more than 2,000 in our community, so I'm sure there's enough people who want to write bootloaders for the devices that we get from. It's good. It's good for experience. It's good to have your code up there. It's good to have your code being seen, being run. So that's going to be the permanent solution to the security problem.
Yeah. Okay. Got it.
Okay, so are there any other questions right now? Anything that anybody wants to know about the RTFES platform specifically? Is there anything over in the chat, Zacck, if you could check real quick for me?
The only question was from Bernard, whether the lab is going to have multiple cameras, and really, I'm sorry, dude. I know it's a lot of, I know it's a lot more work and a lot more stress, but yes, it's going to have maybe even 3, because you need one camera to point at the microcontroller, and you need another camera to point at whatever peripheral they want to use. And more than likely is the motors are going to be sitting in their own section of the server, and the microcontrollers are going to be sitting in their own section of the server. So you'll have a few video feeds to contend with. We don't know how this is going to turn out. We're just trying, and we're going to try as hard as we can to deliver something and see. Nothing ventured, nothing gained. So, and Brandon, as you were asking, the other peripheral for AI is this little guy, which is the MPU 6050 immune sensor. So this guy knows whether you go left, right, up, down, and whatever. All those gestures I used to make. Yes. Any other questions? I see Noah is also typing a question. Or something.
So now back to the originally scheduled programming, which was around the AI recognition application project in the first place. So we do want to take your guys' questions, and actually the reason that we cut in here was sort of to give you an opportunity to use like some infrastructure and try some things out yourself and see what happened. So what we would like for you to do is if you have questions, you can certainly ask them now of Zacck. We have another 10 minutes or so. Or really the best thing to do would be to also put those things in the server. I don't know how many of you are active on that project, but if you can type in your questions here, or you can type them into the server. We will go over those with you, but we'll come back and do a more formal closeout of this project next week, and then after that we'll be getting into some C++ stuff, and then beyond. But for those of you who have any questions, is there anybody who needs help or anything? Please let me know. I did drop a Calendly link into the chat here, and that you can use that to sign up for a time slice for RTFES. That's going to be starting later on next week. Just let us clean some stuff up. So click that Calendly link and take a time that's on the Calendly there. Noor has a question. I want to implement RTF Lite on the STM32 IDE after configuring the AI drivers there. Can someone help me with the steps, or are they done in the last session?
So we didn't end up using the AI driver plugin, or I think it's some Star AI or something, the AI driver plugin on STM32 IDE. In fact, we didn't even end up using an IDE at all. I think what we ended up doing was building TF Lite into a library that you could include in your project using CMake. Because we also had a period there where we either had to learn Bazel from Google, which is a build tool, and we couldn't figure that out. So we ended up finding a way of building the TF Lite as a model. And yeah, I was going to volunteer him, but Taj is always available for this. So if you're on the server, just tag undefined for all your AI problems on microcontrollers. And if you also have AI problems on single board computers, which is like Raspberry Pis and such, you can tag Wafa. Those two people are very skilled at that, and they should be able to help. And in case you're not getting the help you need, which I doubt, you can tag me as well, and I'll be able to at least point you in the right place or get you asking the right question.
And if he doesn't respond, you can tag me, and then I'll yell at everybody. Actually, so for those of you who have questions, please keep them coming. Either here or in the server. I'd be happy to answer any of them that you got. I want to see if Wafa's here because she was she got an assignment last time, and I wanted to see if she's made any progress. I think I saw her here earlier. Wafa, I'm about to invite you on, so hopefully you're by your computer and listening. Hey, Wafa.
Hi, everybody.
How are you?
I'm good.
Happy Sunday. Do you want to give us an update on the project that you sort of got kicked to last week and what's been going on since then?
Yes, actually, I figured it out. Actually I'm using Edge AI, Edge Impulse, to deploy a model to ESP camera. I actually figured it out, and I actually wrote.
Oh, don't do it to us, Wafa. She actually
Well,
did something. We'll never know.
she did report it on the server. I'll go on Waffle's defense. Yeah, she was going to run Edge Impulse object detection, and she got it working, but she was stuck for a while with getting the ESP32 camera module to work. But she did figure it out. I think last night or the day before, I saw the progress somewhere on general or something. She did figure it out.
Yeah, it was in general. So those of you who are part of the server, you can check out those two links. One of them's the GitHub repo that Wafa's been using with Edge Impulse, and then the other is the link to her comment in the general chat. So you can check those out if you're interested in going down the more I don't know if it's a commercialized AI framework route than what the project really initially started off with. Okay, cool. Well, what else, Zacck? What else, Bernard?
Watch for updates, I would say. That's the best thing. Yeah.
Yep.
Watch for updates and ask for them. That's all. That's
Yep.
really it.
For sure. So, like I said, I put a Calendly link in here, calendly.com/techyloo/RTFES-time-slice. And you can pick a time that's towards the end of the week, and hopefully we'll have some things ready for you to jump in and flash. The other thing that I want to bring up before we sign off for the day is that Zacck did foreshadow a couple of different projects, and we've got to write some essentially test cases for these. But now that we can partition them logically, Zacck, do you want to talk about the two projects that we're going to be introducing during the second half of next office hours that are for our very short advent of code?
Yeah. No. It ended up being advent of code by
preemie Jesus
on WebRTC rather than by the community on embedded hardware. That's what it ended up being. Okay, cool. So the intention for all of this system to kick it off and get everyone using it was in the first, as soon as we have this system going, you're going to be able to write a challenge where you can operate this LED matrix. It's a 32 by 8. 1, 2, 3, 4. Yes, it's a 32 by 8. And you will be able to use the ST, which is the blue target, to write, to show video, to play images, to do pixel animations and whatever on this device. And then alongside that, we will also have an ESP32 powered 4 degree of freedom robot arm that you should be able to write code for and also operate. If you're clever enough, you can make the ESP32 move the sensor for gesture on the STM32, and in some way we can use the AI gesture recognition that Taj has been working on for the last few months. We'll see how it all comes out, and once we can deliver all of these features, we'll try to put them all together. But yeah, those are the two projects that we wanted the community to start with. But if you have something that runs on the onboard LEDs or the onboard PWM or frequency counters, or there's a lot of sensors on that little device. There's a microphone, there's there's a microphone, there's an audio jack. There's a lot of sensors on that little device that you can use, that you should be free to test without the other hardware. So even if you don't want to participate on the target hardware, if you want to participate on the target MCU, your code is also welcome and you can see it run. So yes, those are the challenges that are going to get this lab going for everyone.
Yep. So I am again putting this down into a more digestible format. So I'm going to put in here number 1. So doing this gesture recognition application or project on RTFES, and this is really to help us. I don't want to use the word break it, but help us test it.
Yes.
So you can find that right now in the chat. So that's number 1. Okay, everybody. Now I'm going to drop this over in Discord just so those folks over there have the pleasure of getting clickable access, and then I'll give you number 2 and 3. So this is project number 1, which is testing, for those of you guys in Discord. All right. Sorry, go ahead.
I suspect most of the people who want to run project number 1 actually want to run Inference rather than project number 1, because that's the most exciting thing I'm seeing about project number 1. Everyone run Inference of their own model or something, which they're welcome to do for sure, just to see if it runs.
Okay, so then Advent of Code test project is, or we'll just call it Advent of Code project for clarity's sake, is going to be the 4x32. Would you say, mate, or is it 4x8?
4x2 LED matrix animations or images, whatever you can do.
Okay, and we'll create a test case for that and put that in the server. It'll show up as an event, and then the second one of those, the Advent of Code projects, is what's that called? How many degrees of freedom? 4 degrees of freedom.
4 degrees of freedom. Robot arm kit.
Okay. So those are the 2 others that are coming up, and you'll have more information about them in the server shortly.
Also,
yep.
Can I ask something? So,
Sure.
Is there anyone who is familiar with robot kinematics, like forward kinematics and inverse kinematics things?
Sorry, I didn't catch that.
I'm sure we'll find someone. Taj is asking whether we have people in the community who are familiar with robot kinematics. The easiest way of finding these people, Taj, is to run into problems and post them on the community, because no one is going to front themselves as.
So to find the people, I have to buy a robotics arm kit so that I can run into problems.
I know a couple of people. I'll ask them.
Yeah.
I'll ask them.
Ah, come on.
Okay, well, I have to go. I've got another thing, but if you guys want to continue talking, you're more than welcome to, or I can close this out.
No, we can close this out. I think it's good enough, and we've covered enough. And thankful for everyone to have come, for sure.
Yeah. So everybody, thanks so much for your time. We always appreciate you coming. And for those of you who are new to the community, make sure that you go and check this out. And we really appreciate your time, and hopefully this is some good stuff for the community, and it can help you in your development journeys. So we appreciate it. We'll see you guys in the server, and have a great rest of your weekend wherever you are.
Thank you. Cheers, everyone. Thank you so much for coming.